All right, this is Lab 4 for CECS 447. In this lab, we are designing the UART to send commands to the console so that it will output different waveforms based on the input. I have it set up right now. Let's reset it, and then let's type in our first one, which is the triangle wave, which outputs on the oscilloscope as triangles. And then when you do the S for sine wave, you get your sine waves. And then I have the sawtooth, which gives you your sawtooths. And then I have the square wave, which gets you your square waves. I have the oscilloscope hooked up to my 6-bit DAC. These are all the different pins connected to the board. Oh, this extra stuff here is not being used, it's just left over. But all that's being used right here is the DAC itself in the R2R configuration. And then I have the oscilloscope measuring here the output. And then it is grounded over here, which is all grounded through the board, and power as well as being provided by the board. All right, so let's go ahead and dive into the code. So I started with the, let's see, under Kyle, Texas, where I started with the provided UART code file, which is provided by the Daniel Bavano book, or the example work that comes with the book. I left pretty much everything default aside from maybe like 1 or 2 changes. I believe the major change that I made was here in the UART out string, just providing the buffer for the characters to output the string to the UART. Phase lock loop, use that pretty standard as well. Haven't really changed anything in here. And then in the DAC, I have the sawtooth, triangle, sine, square wave values for each waveform. My DAC init, which is using the 6-bit DAC, enabling on port B, PB5 through 0. As output, pretty standard stuff, disabling analog, regular functionality, alternate functionality being disabled as well. And then the send init file, again taking a period, and then the wave char, which gets assigned here, telling us which waveform is being used. And then establishes the period based on the input value, which we'll see later in the main file. And then I also have the DAC out here, which, takes the index for each of the different values, and then the waveform, which is assigned up above here, actually gets put into a switch statement, which, depending on which value is entered, will output the corresponding waveform plus the index at that section, and then break out of there. So going into the main file, we have, just including the header files for the different files. Then we have enable, disable interrupts. Let's see. So this is the main that was borrowed from the project file. So some of the stuff was left over, like comments, just to make sure I understood what I was doing and how to go back and reread my code for code readability. Unsigned char in just keeps track of the input from the UART, well, the putty, which is the UART in char. So starting the main, you disable interrupts, then you enable the phase lock loop, you initialize the DAC and the UART, and then you re-enable the interrupts. And then you enter the super loop here, the while loop, where it checks constantly for a UART input, and then if you don't get an input, it just establishes a baseline waveform as the sawtooth. Otherwise, the switch statement here will determine whether it's sawtooth based on W, T for triangle, S for sign, R for square. And then we have a default here. So if you output the wrong thing, you get an input error, and then displaying out to the console telling you like what you can and can't use. And that's about it. What else? Anything else in here? Well, other than it took me a while to actually get a hold of an oscilloscope to actually double check the files due to the fact that school is, well, inaccessible right now. I can't really go to school where I would normally have access to oscilloscope, so I've been finding alternate means to get a hold of one. But that's it. Hope you like my project. Have a good one.